Good morning, Devanshu. Am I audible to you, Devanshu? Please let me know. So in the yesterday session, we had a discussion about transformative physics, right? This is one of the process simulator. Used in many processes, right? Since we have discussed in terms of steady state processes and unsteady state processes, we have to apply different equations. Those may be available, may or may not be available. So this is available in terms of data sets. It's data bank. Okay, the data sets will be available there. Then, based on assumptions, you have to start the process. Okay, so this is the idea about the point which we have discussed in the yesterday's session. Okay. Meanwhile, if you have any doubt or if you have any suggestion, please let me know in the chat box. Good morning, Deepak. I hope I'm audible to all of you. Please let me know. Whether I'm audible to you or not, please let me know. So I was just revising whatever we have discussed in the yesterday's session, right? Because as a part of this syllabus in unit number 3, we have to discuss about the different heat transfer, mass transfer, and fluid flow operation techniques where we can apply this, whatever we have discussed in terms of mathematical modeling. Mathematical modeling, it is nothing but the representation of variables, parameters, right? How they are interacting. So one can say interaction between the parameters, interaction between the variables at particular parameters may be constant. Okay, but you know that doing so manually, it's time consuming, right? Then it's more economic, right? And then it may not be safe. Okay. So what we used to do, we shifted our focus on process simulators. What the process simulator used to do, they used to simulate. Let's say, in other words, it tries to iterate the equations. But what is the basic aim while iterating this? Very important is to reduce the error. Okay, you know the meaning of error, right? Error, it is nothing but the difference between what is the actual values, those are desired in that particular or for that particular set of experiments, and what is your predictor or what is your value that you have gained after experimentation, right? So this error is then divided into, let's say, sum of square of errors, mean errors, right? So there are a lot of terminologies based on statistical analysis, right? So in basic, in general, we have to minimize this error, right? There are a lot of techniques available, as I have suggested you earlier, while doing the manually all the situations, in all these situations, there will be scope of error and which may cause damage to the system. So it is to be minimized, error is to be minimized. So that's why we are going for the iterations. Iterations, as the name suggests, repetitive task. Okay, so let's say if you are doing a kind of experimentation and your aim is to find out particular output or the product, but that, let's say, in terms of desired quality, okay, so there may be different parameters associated with the quality of particular product. So what you have to do, there will be a standard, or let's say standards for that particular process or that particular system. So based on that, there will be comparison between them, right? So what exactly the comparison is? The comparison shows how your desired system is somewhat matching with the standards. Those are set for that particular thing, for the particular process. And if there is any mistake, one can say, or there is something is missing, that is to be analyzed based on this comparison with the standards, right? So you might have seen that yesterday we were discussing in terms of COMSOL multiphysics, where one of the example was for the mixer. So when we are discussing about the unit operations or unit processes, it is very basic to mix two components. And when we will discuss in terms of components, it starts with its basic properties. Let's say whether it is in terms of gases, liquid, or solid, either it is single state, right? Whether it is multi-state, okay? That may cause variation in the process. And if you'll go to the physical system, mixer, it is something similar. Let's say this is a kind of, though there is difference in mixing and agitation, okay, but one must have that assembly. So if you'll go with the physical system, you have to take care of the material which is of which it is made, and how it is going to be affect or going to be create a kind of effect. Both are the different terms, right? Affect and effect, positively, negatively, right? So you can't say that whatever the system is under observation with which you are dealing with, it may or may not cause the desired changes. right? So you have to start with the basics. You have to deal with the different parameters which may be taken care while designing your system. So same we have to replicate in terms of this simulation. Okay. Though we have studied starting from unit number 1 to unit number 3, that you must be aware about the process, its components, then what are the affecting factors, and what will be the final stage, or what is desired product. So based on that, you have to deal with, that is what I have mentioned earlier here, equations, assumptions, mathematical formulae. So this goes on, goes on, goes on. If it satisfies the condition of minimizing the error, then you can say that it is somewhat satisfying the condition of or for the system, right? So our aim is just to check whatever we have discussed in terms of physical modeling, mathematical modeling, or in terms of AI. If you can remember, we had discussion in terms of black box of aeroplane, how the data is recorded and how then it will be post processed in order to track the data during that flight. Okay, so then we came to next part of discussion, that is artificial intelligence. In the artificial intelligence, we have discussed the parameters, or let's say the things like how it is to be trained, how to get the data. There may be the, sometimes you may have to pre-process the data as well. Okay, so training modes, we have seen different training modes. So the idea is whenever you have the parameters in terms of any unit operation or unit process where one can apply this idea of process modeling, simulation, and optimization, one must take care of all the steps. Okay, and for this, the one very important part of the discussion which we started here in yesterday's session, it is like we have gone through this website of COMSOL Multiphysics, which is nothing but the process simulator. Though they have started working on this, like this COMSOL lab in, if I'm not wrong, in 1980s. There are a lot of progress since yesterday. We have seen that, if I'm not wrong, that is the version 5.6. Okay, they are developing, they are making the changes, they are providing user-friendly environment. So the idea is whatever we have discussed till now in unit number 1, 2, and 3, and in unit number 3, let's say we are supposed to work in terms of heat transfer, mass transfer, and fluid flow operations. In last few sessions, we discussed in terms of distillation, adsorption, heat transfer. You are aware about that. Yesterday we have seen the few key points while designing the heat transfer or heat exchangers. The need to design such critical geometries and how to process them for the certain situation, right? So This is very, very important. Right? This is very, very important. So depending upon the data which is available with you, you can statistically analyze it, and based on that, you may be able to set your desired goals. Unless and until you are not familiar with the kind of data you have, at the end, when you will get certain kind of results, you may not able to analyze it, or you may get non-conventional data. Let's say non-conventional, let's say, it may not make that much sense for that particular work. So very important is deal with the errors. Okay, sometimes it will be manual errors, right? If you are using some kind of system, there may be error, so it is to be calibrated, right? There must be calibration. You know that calibration and everything, you might have studied this in your process control, instrumentation and process control course, right? So you know that we used to give the range where it is to be calibrated, by which range it is to be calibrated, where it is on plus minus 10% or 5%. So all these situations are given to you, you know them, and accordingly you have to fix your system. So this is not the matter with only comms or multiphysics. If you'll go with, no, Scilab is not process simulator unless you will go in the somewhat process controlling steps and everything. Okay, there are different situations in the Scilab software as well, but if you will go with the answers workbench, okay, this is the package. I'm writing the name of the package. You may go with the Aspen, right? GameCAD is there, but yes, you may go with this, where there must be accuracy in terms of thermodynamic laws, in terms of appropriate behavior of that variables, because we have to deal with thermo properties. Okay? Thermo properties. So yes, if you can remember, there are a lot of processes which deals, it's either in heat, mass, or momentum. There will be a set of equations based on your variables, based on your parameters, and very, very important is, whenever you are going for this, one part which you must be aware about, degrees of freedom. Okay, then this emphasizes on number of variables and then number of equations, right? So whether your system is in, let's say, whether it will predict the appropriate behavior or not, it all depends on the degrees of freedom, right? If we'll take simple example from your fluid flow lab, okay, if you can remember this, we have to measure, measure, that means MEA, Okay, and this major is something different. Major and minor losses from the system, or let's say in particular bends. We used to say that you have a particular system in the lab where there will be the flow of particular fluid. The system is designed for you in the lab itself, and you have bends, interconnections. So what is our prime aim is? Our prime aim is to minimize the losses, error. This is what I'm discussing from last 10 to 15 minutes. Very important is losses. Okay. So in this situation as well, if you can remember this situation from fluid flow lab, you have to fine tune the parameters. Let's say one is that flow behavior. So there will be the flow meter. You have to fine tune it based on the flow meter. You have to check the length, diameter, the properties of the material, properties of the fluid, very important. That is under consideration for the system. So based on all these parameters, you have to go with major and minor losses. And for this, if you can remember, you are provided with few constants for the particular system. HF, if you can remember, so the constants always provides the relationship, and that comes from the assumptions, right? So these are the situations, and this is the particular situation from fluid flow lab. If you can remember, you have to vary the flow, you have to check how many losses are there. So very important, along with the flow meter, if you can remember, if I'm not wrong, we are going to deal with the pressure as well. You have differential manometer there, right? So the differential manometer tries to provide how much is the fluctuation due to that particular flow of the fluid from that at that particular region. So you used to mention P1, P2 at this location, P1, P2 at that location. So you may design this system, but while taking the readings, there may be errors. See the contradiction. Here, we have to find out the error. We have to find out the losses. At the same time, while discussing about it, once again, we are dealing with the errors or changes that might be occurred, that may be occurred while performing the operation. So all the situations with which we are aware, now you know what are your parameters, variables, dependent, independent variables, right? What are your assumptions? You know about your constants. So most of the things are with you. So what next? Next is, if you came to know that for this particular flow rate, the losses will be something like this. And in actual practice, depending upon the situation, depending upon the ambient temperature as well, there will be a lot of changes. We are aware about it. Okay. So while dealing with all these factors, repetitive work should be carried out in order to reduce that error. And you may say that in order to get the perfect result, one should follow this approach. But yes, time constraint, money constraint, safety. So all this will be, if one has to overcome all these difficulties, one should go with the simulation. Okay. So that is what yesterday we were discussing in terms of COMSOL multiphysics, right? I know, though we have to discuss as a part of syllabus in terms of heat transfer, mass transfer, or momentum. All these are interlinked. But what makes sensible here? Basic information about all these processes and how to club it with any kind of simulator. How to club this information with the simulator. Okay, so this will satisfy the condition, and finally you will be able to get the desired result. Okay, so these are the simulators which can be used. Optimization comes into picture when there will be iterations. Okay, sometimes I will try to show you in the answers we have that with number of iterations. If you can remember, along with u, v, w direction, what are the changes in the system? Okay, so it tries to give like this. So this is, though by looking at this you can say this is small, but when you will magnify it, you may observe that this may create impact on actual system. So this is the overall idea. This is the overall idea that how one can apply process simulators for the particular system, either in the lab or in the industry. Right? Either in the lab or industry. One more, somewhere I have seen that in this pandemic situation, we are struggling to get the results in terms of, yesterday, if I'm not wrong, we discussed in terms of aerodynamics as well. The first, the lab which was set in the Germany. And in that particular situation, German companies, they are best in the world. You might be aware about this, either in terms of automobiles or some other products. They started working on it. Though we are aware about the simple assembly of flow through a pipe, either it may be tubular pipe or circular pipe. Since we are discussing about the flow, what will be the effect of flow in terms of Reynolds number? We know the experiment, how to perform it, how to proceed with this. All of us are aware about it. But what is actually happening here? Boundary layer conditions, analogies, how we are going to visualize it. So this everything will be discussed in terms of process modeling simulation. The optimization, we'll try to discuss this in the fourth unit. Okay. So in the fourth unit, we'll try to discuss in terms of optimization. But here, I feel combining all these aspects in order to get the desired results, either it may be in terms of process simulators or combining different equations in order to get the actual data from the simulator or from the lab, combining them, comparing the data and getting the result. There, just for your information, uh, in most of the systems, you might have heard about data acquisition. Right? Collecting the data, gathering the data, separating it out, and getting the best out of it. Okay? So this work is to be carried out by data researchers, or you can say data scientists. Okay? Data scientist. Right? So this is how this course is going to help you throughout your career. Data is very important in this case. Either it is primary data, secondary data. If it is a primary data, what is the effect on the system? If it is a secondary data, that means not actually taking part in the system, but yes, it creates a kind of impact on the system. Okay, it creates a kind of impact on the system, which is reflected in your final product. So yes, there are many strategies to be designed, developed, and to be tested. So yes, this is the workflow. And at the end, one must consult with these process simulators, which will try to give you large amount of data, and that must be analyzed. Okay, so that was the reason why yesterday we discussed in terms of COMSOL multiphysics. I hope the task was given to you to explore about COMSOL multiphysics, and now you are in position to at least tell about the components of these kind of simulators, and the basic knowledge that may required to deal with these simulators. Okay, so I hope you are getting the point, whatever I am trying to present in front of you. Okay, any doubt? I'm done with today's session, don't worry. I'm done with today's session. Now I'm giving you some time to analyze whatever we have discussed, think about it, explore the terms if you are not aware about. But I don't think so, because we are discussing the same points. Only the vision is different. Right? Now, it's your duty to analyze whatever we have discussed till date, how we can apply this. Okay, and higher order thinking will come later in the month of June, where I will ask you to install some simulators and work on it. Okay, so that will come sometimes like higher order thinking from this course, right? So if you have any doubt or if you have any suggestion, please let me know in chat box, students. In the next chapter, we'll try, in the next session, we'll try to discuss more about this simulation approach, how we can apply it for a particular system. I may show you few conventional methods by which we may proceed, and what is if we can convert that into non-conventional situation like simulator, what will be the difference? Okay, yeah, please let me know any doubt or any suggestion till this point, students. Deepak, Devanshu. Okay, fine. It seems that you guys are quite familiar with the terms. You are getting the terms, whatever we have discussed. Okay. So that's it from my side for today's session. Thank you very much, everyone, for joining this session. We'll meet in the next session with the same link. Till that time, take care and bye-bye. Bye-bye, everyone. Yeah, welcome, Deepak.